Okay, good afternoon. So we're back. It is Wednesday, the 25th of March, and we'll have our first geometry lesson today. Parallel lines cut by a transversal is going to be our point of focus. And there's a lot that we could have started with here, but I wanted to kind of jump into a mid-semester idea to see where we're at together and give you, if you haven't seen it, give you a look ahead as to what we're going to be talking about at some point in your classes. So let's start with a diagram here. Okay. These are lines. Okay, first things first, sometimes we use this type of symbol to denote that those two lines are parallel. Okay, so these are two lines, the ones with the red arrows, that are parallel, and they are cut by a transversal, which is a third line that hits the other two lines at any points. So to have a transversal, two lines don't have to be parallel, but when they are parallel, we get a situation that can look like this, although you can spin it and flip it and things in your mind as a whole and think about all the different ways you might see two parallel lines cut by a transversal. They're all under this umbrella of these have relationships now. And the most important relationship, or kind of the backbone of figuring all the rest of them out, actually doesn't have to do with parallel lines at all. It has to do with just the angle measurement of a line and a supplemental angle. So you might see, and this is an aside here, something like this, right? Where this bottom piece is a line, meaning 180 degrees right there, right? You can imagine, like, if this thing, this little ray here, you can think about it kind of moving, right? Like bring it back and forth in your mind so that it sits all the way down here, and then so it comes all the way back to here, right? You can just flip, 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 flip. Well, we know that then in that rotation there, that's 180 degrees. It's half of a circle, right? So the line angle from one direction to the other is 180 degrees. Supplemental means that if you look at these two angles that are created by this additional ray, okay, we don't know what their angle measurements are. We know they're less than 180, each of them separately, because they're not an entire line or half circle. But together they are, right? So they're called supplemental angles. We'll call this angle A and angle B. So angle A, the measure of angle A plus the measure of angle B will be 180 degrees. And those are called supplemental angles. Okay. So two supplemental angles are angles that are next to each other on a line and add to 180 degrees. Now, take a second here, and you can pause the video if you'd like. If you're live, we're just going to go straight ahead, but you can pause the video if you'd like and think about this. You know, where are supplemental angles on this, right? On this two parallel lines cut by a transversal up here. Where are there supplemental angles? There are several of them. And what I'm going to do is mark them a little bit and then see if I can erase it when we need to start over. So supplemental angles. Well, this angle here, which I'll mark with a dot, is supplemental to this angle. Can you see it? Right, we have this kind of more vertical line cutting down the transversal, cutting down the middle. It cuts across this line here, and that means these two are supplemental. It also means, you can probably see it here, and I'll do this intentionally in blue. These two angles, let me number them. This will be angle 1 and angle 2, the first two we talked about. Now we want to talk about angle 3. 1 and 2 are supplemental. 1 and 3 are also supplemental, right? Kind of have to change your perspective in terms of which is the full line, 180 degrees, and which is the ray or line cutting through it. Well, you might be able to see it, right? That is 180, but this is also 180, right? So they're different 180 degrees when we're looking at them physically, but they're both 180 degrees because it's the entirety of a line. Okay, you might see then we have another angle to contend with here. We'll call it angle 4. Which angle is 4 supplemental with? Well, two different ones, two different pairs. 4 and 2 are supplements. 4 and 3 are supplements. So you can probably see it. So 1 and 2 are supplements. Let me write it actually. I'll do it here. Angle 1 plus angle 2 is 180. Angle 1 plus angle 3 is 180. Sorry about that. The screen is moving. Angle 2 plus angle 4 is 180. And those are all degrees. Get my units right. And angle 3 plus angle 4 is 180. Okay. 4 pairs of supplemental angles. Okay. Then quickly, hopefully you can see up here, we have something somewhat similar happening. That angle and this angle are supplemental. This angle and this angle are supplemental. That angle and this angle are supplemental. Similar set of 4 pairs of supplemental angles. And you can almost see, hopefully, although the diagram that I've drawn by hand isn't perfectly parallel lines or perfectly straight lines, you can kind of hopefully see that that makes a lot of sense. As we move from the bottom intersection to the top intersection, yeah, it's the same type of relationships in terms of supplemental angles, just talking about a different pair of lines together. So I was intentional here with the color that I'm using, right? The ones that I labeled with the red dot and the ones I labeled with the blue dots. And you might see why. You might already be seeing it. If angle 1 plus 2 is 180 and angle 1 plus 3 is 180, then we actually know then that angle 2 and angle 3 must be the same measure, right? They're not actually the same angle. 2 is up here, right? 2 is here, and 3 is here. We're talking about different angles, right? 2 is this angle, and 3 is this angle. But they must be the same measurement because either one of them, if you add them to degree angle 1, which is itself, it's 180. So whatever that is, you can imagine, like, what if angle 1 was 105 degrees, then angle 2 would have to be 75 degrees. And angle 3 would have to be 75 degrees because 105 plus 75 is 180. Okay. Good. So we also know, and maybe you see it, that angle 1 plus angle 2 is 180. Angle 2 plus angle 4 is also 180. That means angle 4 and angle 1 must be the same. So let me write these out. So angle 2 is congruent to angle 3, and angle 1 is congruent to angle 4. That type of relationship, notice we haven't even talked yet about this angle when we're talking about this line when we're talking about these congruent relationships, right? That just has to do with two lines intersecting each other. Two lines intersect each other, they create these supplemental angles, therefore they create angles that are equal to each other. Good. Okay. Now let's take advantage here of the fact, and let me first start by labeling some of these. We'll call this angle 5, angle 6, angle 7, and angle 8. I'm also going to erase this just to give myself a little bit of space. Angle 5, angle 6, angle 7, angle 8, going to label. Now, here is where these two lines, the one that I've highlighted and this line, being parallel, comes into play. Because they are parallel, and because this transversal line here is itself, right? It's not two separate lines, just one line always. Angle 1 is congruent to, do you see that for me what the easiest one to see is angle 5, right? You can imagine these parallel lines, right? Grab this line in your mind, grab it in your mind, and you're going to lift it off the page. Because it's parallel to this one, you can lift it off the page, slide it up, and set it right down. And almost imagine that these parallel lines, because they're parallel, because their slopes are the same, they cut the transversal in the same angle, at the same angles, right? So 1 is congruent to 5. You can see some other ones maybe. 2 is congruent to 6. 3 is congruent to 7. 4 is congruent to 8. Okay. But now we have a lot going on, right? Because we have angles equal to each other, but multiple sets of relationships going on. Because in the same way that we had these two, and let me erase this supplemental stuff here, we also get 5 is congruent to 8, and 6 is congruent to 7 for the same reason as these two relationships above, because they're supplemental angles to the same angle, and therefore they must be the same. Some of our work over here with the green. So 1 is 4, but 1 is also 5 down here, right? Angle 1 is equal to angle 4, but angle 1 is also equal to angle 5, so 4 must be equivalent to 5. 2 is congruent to 3, and 3 is congruent to 7, so 2 and 7 must be congruent, right? You're starting to see the relationships here. But if 2 and 7 are congruent, and 6 and 7 are congruent, then 2 and 6 are congruent. So what's coming out here, and hopefully you're seeing it, is all of the angles that I marked with the red dot are congruent to each other for different reasons, right? For different reasons. Some for supplemental to the same angle, some for parallel lines, right? So all the red dots are congruent. All the angles that those red dots represent. And all the blue dots as well. So two sets of 4 congruent angles when we have parallel lines cut by a transversal. They have names. Kind of the pairings have separate names. So why don't I'll put it down over here. Okay. What are some of the names? Well, corresponding angles. Let me not use blue. Go back to black. That'll be 4 and 8 is one example. Angle 4 and angle 8 are corresponding angles. Then hopefully you can see, like, okay, picture the relationship here of like what exactly is going on between 4 and 8. You can see other pairs of corresponding angle, 1 and 5, 2 and 6, 3 and 7. Those are all corresponding angles. We also have what are called, and these are just labels for what we've already shown, alternate exterior angles. So, for example, angle 1 is congruent to angle 8. They are exterior, and they are alternate sides, right? Like 6 and 8 are alternate, 7 and 5 are alternate, but 1 and 8 are alternate exterior. You can kind of see the relationship here. Also 3 and 6. And you might be looking at the other relationships we haven't labeled and their relationships, right? The other pairs of dots that are the same color, alternate interior angles, say 4 and 5, but also 2 and 7. Okay. But I think really this is, with the diagram, is really the key moment, right? We actually, when you have 2 parallel lines cut by a transversal line, you get 2 sets of 4 angles which are equal to each other, congruent to each other. Okay. Let's see this play out in an example. Okay. Nearly a new sheet of paper. Let's go to parallel lines. So those 2 lines are parallel, and they are cut by this transversal. Transverse being a word to talk about being going across, right? So the transversal line goes across these 2 parallel lines. You can kind of see what that looks like. Let's label some. That'll be L. This is M. This is Q. This will just be so we can talk about angles easier, like which ones we're talking about. That's O, S here, and R here. Okay. So for example, this angle, and this is given to us as well, 105 degrees. So the angle LMQ is 105 degrees. Now sit and look at this, right? This is two parallel lines cut by a transversal. It is the same idea as this diagram. The parallel lines in this case aren't horizontal, where in this case they are, right? SP and RQ, those lines. But they're parallel and they're cut by a transversal. Therefore, all the colored dots that we did up here, all the relationships we found right here, they hold. They hold. Now in this specific case, so LMQ is 105. What does that mean? We're trying to find all 8 of our angles here. Well, for different reasons, that means angle LNP is 105. 105. It means angle RMO, sorry, oops. That fooled me. This is an O down here. RMO is also 105. It also means SNO is 105. Okay. Why? Why does it mean it? Why does it mean that? Well, LNP is also 105 because they are corresponding angles. Notice 4 and 8, and 3 and 7, and 1 and 5, and 2 and 6. Well, LMQ, LNP, those are corresponding angles, right? Now, SNO is also 105 because it's an alternate exterior angle. RMN or RMO is also 105 because it is it's supplemental to the same angle. It's also alternate interior from LNP. Those are always congruent right there. It's also corresponding with SNO, which is 105 because these are alternate exterior. Right? So 105, 105, 105 degrees. Now you can see 4 unlabeled angles, right? And we know from the previous diagram they're all equal to each other. They are all congruent. The real question is, what is its angle measure? Well, this again falls back on the idea of supplemental angles. 105 plus a red dot is 180. So it must be 75. And then for the same types of reasons as we just found for all those 105s, all of these are 75. So it's going to be somewhat a similar situation. You can think about other examples. You can draw yourself a similar diagram and change 105 to a different angle and see if you can successfully find the rest of the angles. In fact, let me just draw you an example, and then I won't necessarily do it, but hopefully you can do it relatively fast. So 2 parallel lines, there's the transversal. If this angle is 115, what are the other 7 angles being this one, this one, this one, this one, this one, this one, and this one, right? Hopefully you can find that. Okay. And last for the day, I want to leave you with what I'd like to talk about next week for geometry, which is going to be some triangle work. But I just want to look at this diagram for a second, and we'll pick it back up then next Wednesday. So let me label it. I'm going to do a little erasing here just to clear it up. This is a triangle ABC. But kind of in the interior of the triangle, there's a line segment here called DE. And what we are given, what we know, we're told that DE is parallel to BC. Okay, so see it. See what that means. DE is parallel to BC. So this line segment and this line segment are parallel. Okay, are you starting to see how this situation is actually similar to two parallel lines cut by a transversal? In fact, two parallel lines cut by two transversals, so done twice. And I'll just see it if you can imagine these two line segments extending on. So although DE is a segment and not a line, you can imagine it going on, and you're in the situation. In BC, imagine it going on, and you're in the situation where all of a sudden, like, this angle must be congruent to this angle because they are complementary what was the name of that? Corresponding angles. Sorry. Terminology is not my strong suit. So that's where we're going to pick up. We're going to start thinking about what are the ramifications of what we just showed about two parallel lines cut by a transversal for thinking about this type of triangle scenario. Okay. Thank you very much for joining. Hopefully that was a help, and I'll look forward to